we're going to see a lot more personalized skincare coming
Oh,
out.
yes.
Small companies are already doing it. They just maybe need a little bit more funding to be able to market what they're doing. But imagine taking a little piece of skin and culturing fibroblasts and then pushing the fibroblasts to produce growth factors. And then you distill and you concentrate those growth factors and put that into your own personalized skincare cream. So it's your own growth factors that are concentrated. So there's a company doing that. Mark Rubin has started a company for that, which I think is really interesting.
That's super interesting.
And then other companies are doing, incredible things with personalized skincare based on your genome and also epigenetically.
Epigenetics, yeah.
Mm-hmm. And then there's companies that are really just, again, focusing so much on the hallmarks of aging. And so you could, at some point with an epigenetic clock, for example, be able to say, I think I need to focus on this hallmark of aging or that hallmark of aging. And there are companies that will be targeting products and ingredients just for that. So we're getting there, folks. We're really getting there where you'll have your own skincare regimen based on your own DNA signature and your epigenetic signature. Much like they're doing in longevity, Patty, where these companies are you draw blood, you send it to the lab, and they find out what micronutrients you're deficient in, and they develop your own
supplements. Yeah,
and that is a supplement just for Ted, and I get to take my own supplement, which I think is pretty cool.
Yeah, and I think we're seeing also similar to the longevity. Whole body longevity, things like stacking peptides, skin peptides. We have so many good peptides now. So I think we're going to see more evolution in that area. And we know we've got new peptides like microdipeptide, which you and I both talked about before, which is a really multifaceted peptide, anti-inflammatory, anti-aging, all kinds of interesting benefits.
Yeah.
So stacking for the skin.
Stacking for the skin. Yeah. It seems like as we learn more and more about peptides, Patty, you're way more of an expert about this than I am, but it seems like peptides can do much more than we originally thought they could.
You're right about that. And, I'm working on that talk I'm giving at MCAS and looking at collagen peptides. And, in the wound healing models, those collagen peptides, those fragments of collagen, make those fibroblasts start healing the wound. They need to be there. Those collagen fragments are part of the initiating event. Because, I keep delving into, how do these collagen hydrolysates that we're taking as supplements really work?
Yeah.
And it really comes down to that more than anything. I think everybody thinks they're a little building block that you're going to be making new collagen with it, but really it's their benefit is that they influence and turn on the fibroblasts to start doing everything that it needs to do to heal the wound. Gosh. They seem to be the initiating event.
So
prolyl, like hydroxyprolyl. They're peptides. They're mostly di and tripeptides that are in the wound that, signal in the macrophages and to turn on the fibroblasts, and they just start the whole engine roaring. Just so interesting.
And on the medical side, we've got a small peptide coming in for psoriasis. It's a Johnson & Johnson product. And, this is interesting because it's an ingestible peptide, right?
I was just going to say, it's an oral, right?
It's
nice.
an oral. And the way that they formulated it and structured the peptide, it's resistant to the gastric enzymes and the acidic pH. So peptides
That's the challenge. It's a challenge.
Peptides are playing a huge role in dermatology, and they will continue to. So even though we'll be talking a ton about these different longevity and regenerative ingredients, which won't necessarily be peptides, but overall, you're going to see companies still focused on peptides. And
I agree.
It looks like it's crossed over into medical as well.
Mm-hmm. It's interesting. Is it a liposomal delivery? How do they stop it from?
No, it's like a ring, apparently, and because of the shape of the peptide in a ring, it makes it very stable and resistant. So it's not in and of itself.
So it's the chemical structure itself.
It's the chemical structure. Yeah, it's not within anything that makes it resistant to the enzymes. It's the actual structure of it as itself.